series, Convergence and Divergence. In this video, we're just going to do some practice where I write down some series and we're going to figure out if the series converge or diverge. We'll also talk about which test to use. We might go over the details, we might leave some of them out, but this is really just some practice for you. So let's take a look at our first series. Let's do n equals 1 to infinity of negative 1 to the n plus 1, n times 4 to the n over n factorial. Which test do you think we should use and why? Well, this is the ratio test. My biggest clue is that there is a factorial in my problem. That's almost always a clue to do the ratio test, or at least that the ratio test will work. If I do the limit as n goes to infinity of my nth plus 1 term divided by my nth term, flip and multiply it, we end up with this. N plus 1 over n will go to 1. And then we'll have 4 on top and an n plus 1 on the bottom. Which means that the series will converge. Why? Because my sequence part, that is the ratio of my terms, is going to 0, which is less than 1. Now, I knew the answer before I started, not only because I wrote the problem, but because I know that a factorial will grow so much faster than anything up top. So I like to say that this factorial will dominate, and I knew that I would end up with something like this in my ratio test. Let's do our next problem. The sum from 1 to infinity of the square root of n over n cubed plus 2n. So I don't want to have to ask you this every time, but I want you to think, before I put the answer, will this converge or diverge, and which test would you use, and how would you know? So when I look at this one, I say this series looks a whole lot like n to the 1/2 over n cubed, because the 2n at infinity is basically nothing compared to n cubed. Which means my original series looks a whole lot like a p series, 1 over n to the 5/2. I know that this p series converges. This looks a whole lot like that converging p-series. So this would be the limit comparison test. If you want to see the work briefly, limit comparison says let's do the limit as n goes to infinity of my unknown sequence part over my known sequence part, or vice versa, it doesn't really matter. And now I get the limit as n goes to infinity of really n cubed over n cubed plus 2n, which equals 1. And since the limit is positive and finite, both series do the same thing. Ready for our next series. Let's do n equals 3 to infinity of negative 1 to the n. I already got an alternating series, it looks like. And I'll do over natural log of n. So it is an alternating series. I know that the positive parts That is, the 1 over natural log of n decreases to 0. So my series converges. So this is not meant to be an in-depth study of all the tests. I have separate videos on those if you'd like to see them. This is really meant as a reminder to kind of put into practice and get some answers quickly. Next series, n equals 1 to infinity of 1 over 3 to the n plus 1. The plus 1 not in the power. There are different approaches, but I'm going to do this one. I know that this looks a whole lot like 1 over 3 to the n, which is 1/3 to the n. Now, limit comparison should work pretty well here, but I'm going to do the direct comparison test instead. Just to get a little practice with this. The direct comparison test says I have a known converging series. I also know that 1 over 3 to the n plus 1 is less than 1 over 3 to the n. So the values in my unknown are smaller than the values in a known converging. So by direct comparison, my unknown series converges as well. Now let's look at n equals 1 to infinity of n plus 1 over 10n minus 2. I'm going to look at my sequence part really quickly. I recognize that my sequence, I'll call it a sub n, goes to 1/10 as n goes to infinity, which is not 0. So without any more work, I know that this series diverges by the nth term test. Let's do a few more. Let me take a look at the series 1 to infinity of 3 to the n over n squared. Now, I already know what happens because a geometric or exponential function grows so much more quickly than the n squared that my top will dominate and this will diverge. Basically, the terms are going to go to infinity. But how would I show that? Well, this is the ratio test. What tells me this is the ratio test? I don't see any factorials. What tells it to me is that I have a combination of different types of functions. So this is another big clue that I would use the ratio test. Let's go through this. Let's do the nth plus 1 term over the nth term, flipped and multiplied. The squared parts will go to 1 as n goes to infinity, which means that my ratio goes to 3, which is bigger than 1, and so I know that this diverges. It's like way out at infinity, my terms are being multiplied by 3 each time. So my terms are tripling, basically. All right, let's take a look at the sum. Let's do n equals, say, 3 to infinity of negative 1 to the n, and then n plus 3 over 4n minus 2. Alternating series, but beware here. Let me just look at this part, the n plus 3 over 4n minus 2, ignoring the alternating part, because it's not going to determine what happens here. that sequence would go to 1/4, which does not equal 0. So once again, this will diverge by the nth term test. It's one of my quick checks every time I do these. I look, does my sequence part go to 0? If not, I'm done. If yes, then I got more work to do. How about we do n equals 2 to infinity of the natural log of n over n. What do you think? Converge or diverge? Which test do you think you would use? Well, this one has two tests that really work here. Either the integral test or the direct comparison test. I'm going to do the integral test. How did I know integral test? Well, because I recognize if I do the continuous equivalent, I have natural log of x over x, which is a classic U sub. So I'm not going to do all the precision, all the b goes to infinity and the proper integral stuff, because the idea here is more about the series. But I will do the U sub. So if U is natural log, du is 1 over x dx. And then my series will be u du. From some number, well, it's going to be I guess I'll put the natural log of 2. If x is 2, u is the natural log of 2. If x is infinity, u is the natural log of infinity, which is still infinity. And then I would get u squared over 2 from the natural log of 2 to infinity, which of course goes to infinity, which means this series diverges. One more test. The series from 1 to infinity of cosine squared n over n squared. What should we do here? Well, what do I know about the cosine? I know that the cosine of n, at least the absolute value, is less than or equal to 1. And the cosine squared of n is also less than or equal to 1. And of course greater than 0. So this tells me I should probably do a direct comparison. Because if cosine squared of n is less than 1, then cosine squared of n over n squared is less than 1 over n squared. I know that 1 over n squared is a converging p-series. Which means by direct comparison test, I have a summation which is smaller and positive, but smaller than a finite series, which means my unknown series converges as well.